Hi guys, welcome back to yet another video. This is Madhukeship. Today I'm gonna talking about second PUC physics blueprint. Second PUC physics to be very specific, because me being from physics background, I thought I would discuss the physics blueprint and the question paper pattern with you people. So to begin with, we have a very simple rule. Like, the physics question paper is basically in two parts. One is the theory part and another one is the practical part. So theory consists of 70 marks and practicals consists of 30 marks, right? So when we split this, your practical 6 marks of record is given straight away to you guys, right? This is literally in your pockets. Then you have 4 marks for viva, 6 marks for record, 5 marks for your viva. Then you have 3 marks for your calculation. Then you have 2 marks for your correct answers, like 2 marks for your correct result with correct SI units. Don't forget the units. Units are very important in physics. So you can count it here. So it's 10, 13, 15. 15 marks is done, right? The remainder of the marks, right? So the remainder of the mark in that 4 mark will go on how you perform the experiment. So let's recount again. 10, 13, 15 plus 4, 19. The remainder marks, the remaining 11 marks is for the write-up, is for your write-up. I'm gonna draw solid line for this. I've drawn solid line for this as well as this, right? This is very much easy to do that, right? 6 marks plus 11 marks, 17 marks is very easy to get, plus 4 marks is very easy to perform. You have to just perform the experiment, and with this you will be able to get 20 plus easily without much fuss in your practical examinations in physics. Majority of you do get it, right? Even you may lose, so there is a chance of you losing marks only in these three aspects, but these three are like solid stuff. If you practice very well the write up, except the procedure like the aim, principle, tabular column, formulas with the right units, then the result, all these things perfectly, then I think you are ready. You should know how to write it. Except procedure, you should practice all the 14 experiments and you will be able to do it with ease. And coming to our, this is a practical breakup. Okay, let's go back to our theory breakup. Now when we talk about theory, we have many people start thinking numericals is hard, numericals is hard. Before opening the book, they keep saying numericals is hard. So let us talk about numericals first. Okay, let us start with talking with respect to numericals. Numericals is basically, you will get two 5-mark problems. So it is for 10 marks and you have 4 choices. Out of 4 you have to solve only 2. Which are the 4 problems you are gonna get? Which are the chapters from which those 4 questions come? Let's go back to the blueprint. So the first chapter, electric charges and fields, has one 5-mark problem. So NP stands for numerical problem in this blueprint. So 5-mark question comes from your electric charges and field chapter 1. Then the second one comes from your current electricity chapter, right? Then the third question, alternating current. You can see here, this is basically direct application formula. So you get one from AC, a direct question, application question. So it's much easier to apply. And then you get one question from ray optics and optical instruments. So these are the 4 chapters out of which the 5-mark numerical can come, out of which you have to solve 2. If I was you, I would definitely study AC problem. The reason is it's application problem and the chances of you getting the right answer is much easier, right? Then I would also choose the current electricity, because Kirchhoff laws, Wheatstone bridge, other ones, if I am the examiner, I would like to ask questions based on those topics. So those are the things you can look forward for. And you can also keep ray optics as backup, but be careful with the sign convention. The chapter name itself says ray, so make sure the ray diagram has a ray mark. Ray diagram should have ray, otherwise the entire derivation can go to dust. So make sure you draw the ray diagrams properly. And these are the ways you can score easily the 10 marks. This is how the numericals is done. And where else, sir, we see the numericals? We also see one 3 mark numerical coming from the chapter of nuclei. It could be basically based on binding energy, mass defect, or nuclear density. These are the three things. If you know the formula, I think you should be able to solve it. It's not that tough. Okay. And these are the problems. So we have got away with the problems. Now let's go back to the actual part. You are not writing the exam for 70 marks. You may like, what? Yeah, I know. You are writing for 115 marks. You can let go this many marks and you have to score only 70 out of 115 to score full. You have to just score 70 out of 115 to say you have scored 70 out of 70. That's full in theory, right? It's very simple because you can let go many things in choice, right? So some of my students say, sir, how do we pass? The pass mark is 21 out of 70. How do we do this? Oh my god, that's a big question to be answered, right? It's very simple. You see this chapter? If I am you, if I am scared to begin with, first let me know how to pass it, then I will think about scoring. So if you think about that context, I think this semiconductors chapter will help you immensely because there is no derivations in this chapter and it is for 9 marks and it's very simple: intrinsic, extrinsic semiconductors, half wave rectifier, full wave rectifier. It's full of theory. It's very simple questions. You can write them with ease. It's like a breeze. Okay, you can start with that. Then you have studied current electricity a lot from childhood. School days you've studied current electricity day in and day out. So 14 plus 9 is how much? 23 marks out of 70. Let us say you did not score in the MCQs 1 mark, but still you have passed. Okay, so that's how it's done. Okay, so you can pass easily. And but we need to, this is not sufficient to get a good seat in any good college. Nobody nobody respects us if we just score this much and just get away with it. So we need to, um, after this you feel like, yeah, I can do this, I can clear the hurdle, but how do I do well after this? Since you have a backup of passing the examination, now now what if I was you? These chapters, the top chapters, are very important, big chapters. So if I study the top 4, I have scored well. And if I study ray optics, all the big things are covered. Okay, I know they are big chapters, but they are easy. So go ahead and study meticulously. And you might be wondering, where do I get big questions, big derivations from long answers? LA stands for long answers. LA stands for long answers. So if you look at those derivations related questions, let me change the color for. So you can see the capacitor, the chapter 2, electric static potential and capacitance has a big question. Current electricity has a big question. Moving charges and magnetism has a big question. Okay, uh, then you can also look at these two, wave optics. This could be like of kind of may or may not kind of things may occur in these particular chapters: wave optics and dual nature of matter and radiation. And let me tell you, atoms, nuclei, radiation, and electromagnetic waves, these are so small. If you have prepared well, that even the day before the exam, within half an hour you can, if you have your own handwritten notes, you can revise them with ease. Okay, so that's how fast you can go. And then in when it comes to ray diagrams, please practice diagrams properly and put the ray arrow marks. Even the entire derivation might be right, and if your arrow marks are wrong, then that goes to dust. So be careful with that. And rest of it is pretty straightforward: electromagnetic induction, magnetism and matter, AC, all these things. So you can see this is the way you can start. And if you make a statement sheet, you can see majority of the questions have short mark, and fill in the blanks. If you know, the questions will be so easy. I don't know who invented it. If you just know the topic, if you just know the topic from where it is coming from, you will be able to solve it. Like if you know from which chapter it is coming by, you will be able to solve it with ease. Okay, so I think with this I would like to wind this particular video, and I would like to wish you all the very best. Stay calm. You have studied well. Stay calm. Make sure the day before the exam you are having your own handwritten notes, and if you are able to glance the entire physics in just 3 hours, okay, of your class 12. So all the very best for your second PU exam. See you in the next video. Thank you very much. Have a nice day.